well either. So that's the condenser coil, and even though I said I turned off the power to 240 volts, there's actually still 24 volts going to the contactor. So this guy right here, that's the contactor. So the 240 volts consists of two 120 volt legs. So this wire and this wire. So 120, 120 would give us the 240. 240 volts goes in there, but the contactor coil is actually powered by the thermostat or the furnace control board. And if your thermostat is calling for cooling, this little plunger will be pulled in, and there's actually going to be 27 volts present at these two terminals. That's not enough to really hurt you, but just so you know, there is voltage present there if your thermostat is calling for cooling, even if you have your disconnect plug out. So if you touch something metal to it, it will short it out and likely blow a fuse inside of your furnace control board. And the source of this 24 volts comes from inside the house. So if I were to trace this yellow and blue wire, they go into these wire nuts right here. On the bottom, they kind of go right through there and come into here. Once again, I apologize about all the cottonwood. In my area, this just happens all the time. Anyway, these wires go into these wire nuts, and then in turn, come out of this brown wire right here. This is a 2-wire thermostat wire, and this is just zip tied and taped to the electrical whip, and it goes right back up to my disconnect and into the house, and then from there it goes down into the control board of the furnace. And sometimes that wire is going to be mounted to the suction line, this thicker insulated line, and also go into your house through one of these openings right here where the pipes go in. And while I'm here, this is called the line set. These two pipes are basically the pipes where the refrigerant or the freon travels. This thinner one is called the discharge line, and the thicker one is called the suction line. The thicker one is always going to have insulation over it, whereas the thinner one will not. So if we follow them, so here's the thicker line, and here's the thinner line. So this is our line set right here. But we'll get back to these. Let's go back to the contactor for a second here. I wasn't quite finished explaining what this is. This is a relay, a control relay. Basically the thing that controls when the air conditioner comes on and off. So like I was saying, there's 240 volts that comes into the contactor right here. And the thermostat controls this little plunger right here. In my case right now it's pulled in because my thermostat is calling for cooling. So if my disconnect plug was not out in the disconnect box there, my unit would be running right now. So the contactor is simply a control relay. When the thermostat calls for cooling, it sends 27 volts to the coil. It pulls the contactor in, the plunger right here gets pulled in, and that allows the power to go through and turn on the unit. If you have a 2-stage condenser unit, sometimes there's going to be 2 of these contactors in your unit for the first stage and the second stage. And moving on, we have the capacitor, which is almost always going to be a silver cylinder like this. This is the run capacitor, and the technical explanation is a little bit more difficult, but I like to just simply explain it as, you know, it's almost like a car battery for a car, whereas the capacitor is the battery for the condenser unit outside. And I actually have a spare capacitor right here in my unit. This is how one would look like. You got the rating of it and stuff, and I have a whole video of how to replace a capacitor where I talk in detail about all of this, so I won't go into the nameplates and stuff. You got the terminals here. This is a dual run capacitor. Sometimes there's a single capacitor where it'll have just 2 of these sections instead of 3. And notice how I'm touching these terminals. I just reminded myself, even with the power off, this capacitor, it's almost like a battery, it'll actually have a charge stored in the capacitor, especially with a hard start attached to it. If you put your fingers and accidentally short those terminals out with your finger, that can give you a really big shock. So if you took the door off of your air conditioner and you have the power off, just don't touch any of the terminals, any of the wires, because there might still be power present at the capacitor, and that could give you a good zapping. So moving on, from the dual run capacitor, we got the hard start kit. This is like a start assist. It helps the compressor start. This has nothing to do with the condenser fan. This is only for the compressor. This hard start kit is only in the circuit, in the electrical circuit, maybe for, you know, like a second at most, to help the compressor start up. It gives it a kick start in the beginning, and that reduces the wear and tear on the compressor at startup, which increases its lifetime. So this is a hard start kit. Sometimes it'll be a 521 relay. So it'll be a black start capacitor, it would be called, with a little box, a relay, potential relay that controls it. There's two different styles, so it can either look like this with just two wires coming out of it, or it can be a black capacitor with a potential relay, and there will be a few more wires to go with that one. Okay, so I think we covered pretty much everything inside of here. We got our refrigeration pipes, we got our hard start kit, dual run capacitor, the contactor. This is a single pole contactor. By the way, sometimes there's also a two pole contactor where it'll have two plungers, and there's other times where the two pole contactor will actually have a little plastic cover over it. So you won't actually see the plunger, but if you take two little screws out, that cover comes off and then the plunger is revealed. Then we have the condenser coil and our line set, which are these refrigeration pipes that go from the condenser unit outside into the A coil, or the evaporator coil that's inside the house. And I'll cover that in a little more detail when we actually go inside the house. And a couple other things I want to mention. My unit does not have these, but a lot of other air conditioners do. Some units will also have a low pressure switch and a high pressure switch, and those would be mounted on your refrigerant pipes, either when you take off the door, somewhere here, or inside of the coils. You know, you'd have to look from above your unit and look down. But the low pressure switch and the high pressure switch are there to just shut the unit off if there's something wrong in the refrigeration system. So for example, if your freon pressures are too low, that can cause the unit to start to freeze up. So that low pressure switch, when it senses that the pressures are getting too low, it would shut the unit off. And that low pressure switch is an automatic reset switch. So once the unit turns off, the pressures will start to gradually go back up. And once they stabilize, the unit will turn back on automatically. The low pressure switch will always be mounted on the thicker line, on the suction line. The high pressure switch would always be mounted on the thinner line. As for the high pressure switch, it'll shut the unit off if the pressures inside of the unit are getting too high. Another thing on the liquid line, or the discharge line, is a liquid line filter dryer. I don't have one right here to show you, but basically that component would be brazed into the line. And the purpose of that liquid line filter dryer is to filter out any moisture or water or any kind of debris that may have gotten into the refrigeration system if somebody was hooking up their gauges to check pressures. And one last thing I want to cover on this side is the service valves. So the service valves is the spot where you would hook up your gauges to check pressures. And if you wanted to do a pump down or seal off the compressor and the condenser unit, this is the valve that you would use. Here's the access ports right here. And just to show you what they look like on the inside, I'll go ahead and take these caps off. So here's my stem right here. I can put a wrench on it and open the valve or close the valve. A lot of times you'll need a little refrigeration wrench to do this. This is a 2-position valve that I have. In fact, let me take one of these caps off too, so you can see what's behind the access port. I'll take this one off right here. This is where you would hook up the gauges. So the hoses from your gauge set would be hooked up to this access port. I have a little Schrader valve right here, which means that this is a 2-position valve. There's two kinds. There's a 2-position valve and there's a 3-position valve. And there is a pretty big difference between a 2-position valve and a 3-position valve. The ones I have are the 2 positions, and they're always going to have a little Schrader on them, whereas the 3-position valves are just open ports. There is no Schrader valve in there. So you have to hook up your gauges, take off the valve cap, and then open up the valve before you can measure the refrigerant pressures. And while we're talking about service valves, as I was saying, there's a difference between 2-position and 3-position. With the 3-position valve, let me tell you a quick story. When I was going to school, when we were going over refrigeration, how to check pressures and how to troubleshoot and stuff, one guy in the lab, he had his gauges hooked up to the unit, and it was a 3-position valve. In those cases, you have to put on your hoses and then open up those valves. And by the time he was done troubleshooting, he already forgot that it was a 3-position valve, and he thought it was just a regular Schrader valve. And with Schrader valves, you can just open them up and take the hose right off. But with a 3-position valve, since there is no valve, if you start taking that hose off, the refrigerant is going to just come blasting out. So anyways, that guy, he forgot that it was a 3-position valve and it was fully open. So when he started taking his hose off, this was a 410A unit, so the pressures were a little bit higher, and it was bigger unit too, so there was a lot of refrigerant in there. When he started taking his fitting off from the 3-position valve, that whole fitting just ruptured and blew up. And then the refrigerant just started spewing out like crazy. He had a minor frostbite on his hand. Luckily, within like a week or two, that just went away. But seriously, that whole lab, with where all the air conditioners are and all the furnaces and stuff are, that whole lab was just a big haze. They got all of us out of there and then opened all the doors and stuff. And it took it probably a good 3 or 4 hours to completely air that stuff out. It was just a really misty fog from all the refrigerant that got spewed out. So I just want to remind any technicians that may be watching this video, any new technicians, or maybe if you're going to school, if you have a 3-position valve, keep in mind that it has to be fully closed before you take your hoses off. Otherwise you can have a little accident like that guy at my school had. Okay, so last but not least, we have the main components of the condenser unit, which is the condenser fan motor and the compressor. So I already took the screws out that hold the top grate, and then I can just take this whole top piece off. Most of them are going to be like this, and I'll just flip it over so we can take a better look of what's inside. So almost all air conditioners, the condenser units, they'll have a sleeve like this where the wires go into. And the purpose of this, when the fan is spinning, if the wires are a little bit loose, the fan can cut them up. And I've seen fans cut wires or get jammed on wires before when they don't have a sleeve like this. So all units should have a sleeve like this. If you don't have a sleeve on your unit and your wires are kind of loose, I would recommend taking a zip tie and just zip tying the wires to the grate slots. Just like 3 or 4 zip ties so the wires are not loose, otherwise the fan can get to them. So here's the condenser fan motor right here, and then the shaft goes up and the blade is mounted to the shaft. If you ever have to replace a condenser fan motor, while you're ordering the motor, I would recommend putting some rust buster or WD-40 or some kind of penetrating oil in here and just letting it soak for like a day or so, if you have the time. If this soaks real good, you're going to have a lot easier of a time pulling this fan blade off of the motor so you can put it onto the new one. Otherwise, pulling the fan blade off the motor can be quite the task. And I also want to point out that when your unit is running, the air should be getting scooped by the fan blades. So it should be scooping the air, not the other way around. So in my case, it would be spinning this way and scooping the air. And almost all condenser fan motors will have a little wiring diagram on the side of the motor. So if you need a new motor, you can get the information off of this motor. It'll tell you what horsepower it is, what RPM it is, and with the model and serial of the unit, you should be able to find yourself the right motor that you need for your unit if you need to replace the motor. And last but not least, we have the compressor. And the compressor is the thing that pumps the refrigerant. It's basically a continual loop. The refrigerant goes from the compressor to the evaporator coil inside of your house. That's usually on top of the furnace. And then it comes back to the compressor, and it just keeps pumping it in a circle over and over and over. I don't know, later on I might make a video on just the refrigeration cycle and how that whole process works. But anyways, the compressor is the thing that pumps the refrigerant. There's primarily 2 kinds of compressors for residential HVAC. One compressor is the reciprocating compressor, where it uses pistons to compress the refrigerant to make it into a higher pressure refrigerant. So low pressure goes in, and after it compresses it, high pressure refrigerant comes out. So it can be a piston compressor or a reciprocating compressor, or it can be a scroll compressor. Those are usually taller and skinnier. And those scroll compressors, inside of them, it's just one fixed scroll, big metal scroll, and the other scroll, there's 2 of them, is an orbital scroll. So one scroll moves around, the other one is fixed, and that's what compresses that refrigerant to make it go into a higher pressure. So that's the compressor. The compressor is pretty much the main component of the condenser unit. If the compressor goes bad, many times you end up replacing the whole entire unit. And here's my coils from the inside. After they're washed and cleaned optimally, this is how the coils should look on the outside as well. If you're going to be washing your unit, if it's easily accessible, it's preferable to wash it from inside out. Otherwise, you can always wash it from outside in as well. It doesn't make too terrible of a difference. And I forgot to point this out in the beginning, but all condenser units, almost all of them, will have the nameplate on the outside of the unit somewhere, typically where the electrical stuff comes in. So here's my nameplate. That'll tell you, the model, the serial, what kind of refrigerant is in the unit, what the amp draw should be, and all of that stuff. So the unit information will be on the nameplate somewhere outside the unit. And another thing that I didn't quite explain, just brushed on earlier, is the power saver switch. Not everybody will have this, but the power saver switch is from the electrical company. It has really nothing to do with your unit. Most of the time there will be outside, mounted by the disconnect box. Sometimes it can be inside as well, but this power saver switch basically, you know, when there's a high demand for electricity, when it's really hot outside and everybody's using their AC at the same time, to prevent brownouts, the electric company installs these things, and what they do is cycle, you know, half of the neighborhood on and half of the neighborhood off for like 20 minutes, and that kind of alleviates the stress from the electrical grid. But that's not necessarily a very good thing for your condenser unit if it's coming on and off like that. And on really hot days, if your unit comes off for 20 or 30 minutes, that can cause your house to warm up pretty quick. So most technicians don't really like these saver switches too much, but they are there. Electric companies installed them, and you probably get a little discount on your electric bill because you have one of these things. Well guys, and that's about it. I believe I covered all the air conditioner components of the condenser unit outside. We still have to cover the inside, but before we go inside, I also want to touch on the heat pump. A heat pump is pretty much going to look exactly like a condenser unit, like this, like a straight air conditioner, but it'll have a few additional components. And let me tell you a quick true story. It's kind of funny. When I went to school, it's a 2-year course, right, for HVAC. That is divided into 4 semesters. And before I went to school for HVAC, I had just finished my accounting degree, so I was completely clueless in anything HVAC related. So after my first semester of HVAC, I got my first HVAC job, and unfortunately we covered heat pumps on our second semester. So I didn't quite know yet how a heat pump works or even what a heat pump was. So I was with the senior tech, and we were working inside in the basement, and after we were done looking at the furnace, we went back in the van, and he was doing some paperwork, and then he turns to me and says, "Hey, do you think you could go grab the model and serial number of the heat pump?" And I say, "Oh yeah, sure, no problem." I hop out of the van, and as I'm walking down the driveway, I'm thinking to myself, what the heck is a heat pump? So I go back inside the house to the furnace, and I'm looking around. I'm like, man, was there maybe a boiler here or some kind of pump? I'm looking around, and I can't find anything. I'm thinking, man, was he talking about the water heater perhaps? So just in case, I took the model and serial number of the water heater. I come back out to the van. He asked me, "Hey, did you get it?" I'm like, "No, sorry, I couldn't find it." And I don't know if he was just being nice and didn't want to point out my ignorance, but he just turns to me and says, "Oh, you probably went to the wrong side of the house. The air conditioner unit is actually on the right side." So that was the day when I learned that a heat pump is pretty much the same condenser unit, except with a few more components. And that's why I want to point those out to you as well. If you're not sure if you have a heat pump or just a straight air conditioner, if you look from the top at your refrigerant pipes, if you have a heat pump, you're going to have a reversing valve, and I'll put up a picture of that so you can see what that looks like. And it's pretty distinctive. It'll have 1 pipe going in and 3 pipes coming out. If you see a reversing valve, that means your unit is a heat pump. If you don't see a reversing valve, that means you have a straight air conditioner, not a heat pump. And another thing that a heat pump has that an air conditioner does not is most of them will have an accumulator tank, which is a black cylinder. It's a little smaller than the compressor, but that accumulator is in the suction line right before the refrigerant goes into the compressor. And the function of that accumulator is to prevent any liquid refrigerant from getting into the compressor, because when it has to compress any liquid refrigerant, the compressor really struggles. And because heat pumps are made to run in cooler weather, oftentimes they will be raised from the floor. I guess that depends on what area you live in as well. But the heat pump, especially if it snows a lot in your area, it has to be high enough off the ground, so if it does snow and it's not that cold outside, the snow will not cover up half of the coil and restrict the airflow. But really, if there's a lot of snow on the ground, that probably means there's a good chance that the temperature outside is pretty cool. And most heat pumps, they're only efficient when it's, at the very lowest, 20 to 30 degrees Fahrenheit outside. If it's lower than that, then there's not a lot of heat to absorb from outside. So running your heat pump is actually going to cost you more than just running your gas furnace or your electric furnace instead. And when the heat pump is in heating mode, after a while it'll start to be covered with frost. That's why most heat pumps will also have a defrost cycle, which is controlled by a defrost control board, and it'll actually have a defrost thermostat as well. So that defrost thermostat, generally after about running for half an hour or so, it'll turn the unit off and reverse the flow of refrigerant as it would for cooling to defrost the coil outside and make sure that no ice is building up. If for some reason that defrost thermostat or the defrost control board fails, the whole unit outside could start to freeze over. And lastly, the thermostat in your house that controls the cooling and heating. For a heat pump, your thermostat will be slightly different. Most thermostats, they'll only have cool, off, and heat. With a heat pump thermostat, your thermostat's also going to have an emergency heat option, or AUX, auxiliary option. So you can either use the heat pump for heating, or you can use the emergency heat, which is generally either a propane or a natural gas backup heat source that you could use. Well, and that's all I had to say about the outside. Let's go and check out what we have inside as well. Okay, so now we're at my furnace in the basement, and actually quite a few homeowners don't realize this, but part of the air conditioner is actually inside as well. So you have the condenser coil outside, that's the big outside unit. Inside though, usually on top of the furnace, but depending on how your furnace is set up, it could be, below the furnace or on the side of it. In most cases it'll be on top, at least in my area it is. On top of the furnace you're going to have the A coil, also known as the evaporator coil, which is going to be behind the sheet metal, or sometimes it'll be a metal box. They call that a cased coil. But behind this sheet metal, which is typically referred to as a plenum, behind the plenum there's a coil, which looks like a radiator, just like the unit outside. Typically, it's like the letter A, and my air conditioner just turned on. This is a good opportunity to show you the power switch as well. This is the furnace power switch, but if this switch is off, that also turns off the air conditioner outside, because the furnace control board is the one that sends 24 volt power to that contactor coil, so that plunger pulls in. So if there's no power, that means there's no 24 volts going outside. So if the power switch is off, or if the breaker is off, your AC will not work either. So anyways, I shut that off so it's not interrupting me. The A coil on top of the furnace, the job of the A coil is to basically collect humidity from your house and also to absorb the heat from your house. So the air goes through the A coil and then gets dispersed back into your house. And as it goes through that A coil, it absorbs heat through the freon or the refrigerant, and the heat gets dispersed or rejected outside. And the air that goes past your coil becomes cool air. Usually it's about 15 or 20 degrees cooler after it passes through that coil. So as I was saying, usually it's like a letter A. Sometimes it could be like a letter N or even a W. They started making bigger coils, but the most standard style is that letter A-shaped coil. So right here we have our line set. These are the same two pipes that we saw outside. They go into the evaporator coil. You can't really see it because it's behind the metal. And another important component of the AC unit is the metering device. There's a couple of different metering devices, and typically it'll be behind the sheet metal as well. You can't see it. There's either a fixed orifice, which can be a piston or capillary tubing, or there's a TXV metering device, which is automatic. It regulates the flow of the refrigerant automatically. And the metering device is, in simple terms, it's basically just a very small hole that meters the flow of the refrigerant. So as the compressor is pushing the refrigerant in and forces it through that hole, that high pressure refrigerant, after it goes through that small hole, becomes a low pressure refrigerant, so the pressure drops. So essentially the purpose of the metering device is to drop the pressure of the refrigerant or cause a restriction in that discharge line. And as I said a little earlier, the main purpose of the air conditioner and that evaporator coil is to dehumidify the house. So the humidity that it collects out of the house, it runs down that coil, and on the bottom of the coil there's a drain pan. Usually it's about an inch and a half tall. There's a drain pan that runs along the bottom of that coil. All the water that gets collected from your house, humidity and moisture, runs down the coil, and then it goes into this fitting right here. Usually it's a plastic fitting, and then down the drain line. So the drain line, it can be a clear hose like mine, or it could be solid white PVC pipe. So you'll have a drain. Sometimes this drain gets plugged just from time, debris, and whatever else. Maybe the coil's rusting a little bit. will plug this up. I've seen bugs in there, ladybugs, box elder bugs, plug this thing up. So it's usually pretty simple to take this thing off and clear it out. Otherwise, you can try to blow air backwards into it. But of course, the purpose of the condensate drain line is to drain all that condensate or the moisture that it collects into the floor drain or a drain pump if you have one of those. And another thing I want to point out is that the air filter for the furnace is actually the same filter used for the air conditioner as well. In fact, the air conditioner uses a higher fan speed than the furnace does, so the filter will actually get plugged up even faster. So during your air conditioning season, don't forget to replace your filter every month or two. If you have 1-inch filters, or if you have thicker filters, then you should replace them every 3 or 4 months. So that's the filter, and as I was saying, the filter is used for both the furnace and AC together. Same with the blower motor that's inside the furnace. The blower motor is used for both the furnace and AC as well. So they share the same blower. So here's my blower compartment. You got the big blower housing. My blower motor is on the side right here. And most older furnaces that don't have a variable speed blower motor will also have a capacitor. Usually the capacitor is mounted on the blower motor housing, which is right there. Once in a long time, if you get unlucky, your capacitor is going to be mounted in the back somewhere. And one last component that the air conditioner uses is the control board. So the control board sends power to your thermostat, and then when there's a call for cooling, when the thermostat calls for cooling, or if you set the set point down, it sends power back down to the control board, and then the board sends power out to the unit outside, to that contactor coil. The plunger gets pulled in, and your AC turns on. So my control board looks like this. More commonly, the control boards will look something like this. They'll be flat, or maybe something like this. So once again, the furnace and air conditioner, they share the same control board as well. And that's about it. I believe I covered all the air conditioner components outside and inside at the furnace. And now you know what all the AC components are and what they do. Well guys, thank you so much for watching this video. That's actually all I had for you today. If I missed any of the components, please let us know in the comments below, or if you have any other pointers or explanations about anything that you saw, please let us know in the comments below as well. Thank you so much for watching this video. Don't forget to mash that like button on the way out, and we'll see you next time. And if you're still here and not in the comment section below, recently I was asked, where do I see myself in a year? And I said, you know, I really don't know. I don't have 20/20 vision. But let me leave you with a tip. A few weeks ago, I was visiting my brother, and my 2-year-old son, he went into a room, and it had one of those locks, you know, that you could lock the door with. He went inside, closed the door, and locked the lock. And a few minutes later, we hear him crying his head off. So I go over there, and sure enough, the door is locked. My brother-in-law comes over too, and, you know, we start trying all the tricks, the credit card, the fork, the knife. Nothing is opening that door. And that's when we learned a cool little trick that I want to pass on to you. Maybe you'll find it useful someday. What you have to do is, as he was sliding a knife in between the, you know, the door frame and that door lock to try to open it up, all I had to do was take the doorknob and pull away from the door frame. And literally, I mean, it took us like 5 minutes trying to open it up, but once I pulled that door away from that door frame, that little bit of space that I created, that was just enough. He had the door open in like 5 seconds. So if you ever have to open a door, I hope you will remember this and it'll come in helpful for you then.